For the next question, question 7, we have y is equal to 2 over x minus k. K is a positive constant. This is important. Sketch the graph of C. For this one, for explanation purposes, I'm going to show you, first of all, our graph of y is equal to 1 over x. It's a very standard graph. It just looks something along the lines of this. We have asymptotes at x0 and y0. Now, for our graph of y is equal to 2 over x, it's going to be about the same. It's just that the graph it affects the y, so it's elongated. But when you're sketching the graph, it's not going to make much difference unless they're asking you to draw on the same graph, and you have to compare, otherwise it's the same. But really what we're working with is y is equal to 2 over x minus k. If this was our f of x, then this is our f of x minus k, and we know this affects the y units, so this is going to be our x and y minus k. We don't have any coordinates yet, but what we do have are the asymptotes, so x stays the same, and 0 minus k is minus k. So since we know that it is a positive constant, the minus k, if there's a 0, it's going to go down. Over here, let's just assume over here this is minus k. Draw a little asymptote line, and then it's going to be about the same. It goes down like this. Apologize, my drawings are not the best. Now, it does say it is important in Edexcel when you're sketching graphs to label the coordinates of any intersections with the coordinate axis, and we see one intersection over here. How do we solve that? We only know that at this point y is going to be 0. So what we can just solve it, 2 over x minus k is equal to 0. That means that 2 over x is equal to k. We move the 2 to the other side, so x is equal to 2 over k. Hence, this point is going to be 2 over k and 0. That's about it. You get 3 marks just for having the correct shape, and also writing the asymptote y minus k. So this one and the correct shape. Now, in the next part of the question, we're given that the line L has equation y is equal to minus kx minus 6. Given that L intersects C at 2 distinct points, find the range of possible values of k. With questions like this, we're given how many times they intersect, and we're asked to find a range. Our first thought should be the discriminants. So we know that when they're intersecting at 2 distinct points, b squared minus 4ac is greater than 0. But since we have two equations, we're going to want to equate them to each other. So minus kx minus 6 equals to 2 over x minus k. What I would do is get rid of the fractions, so multiply everything by an x. So that gives us minus kx squared minus 6x is equal to 2 minus kx. Just bring everything to one side. Minus kx squared minus 6x minus 2 plus kx is equal to 0. Bring the like terms to one side. Minus kx squared minus 6x plus kx minus 2. Just going to rewrite that. Minus kx squared plus minus 6 plus kx minus 2 is equal to 0. Now we have a quadratic, so we can see that our a is minus k, our b is, I'm going to write this as k minus 6, and our c is minus 2. Alright, so what we're going to want to do is use the discriminant now, which is k minus 6 squared minus 4 minus k minus 2 is greater than 0. So if we were to just open this up, we have k squared minus 12k plus 36. 4, this is going to be plus 4k minus 8k greater than 0 again. So that's going to be minus 8 minus 12. K squared minus 20k plus 36 is greater than 0. And then we can just plug it into our quadratic calculator. 1 minus 20, 36. So we have k is equal to 18 and 2. Now, most calculators do have an inequalities option, but you should know how to solve this. If you were to imagine like a little graph, quadratic, kind of looking like this, doesn't have to be exact. This is our roots, 2 and 18. We know that the graph is greater than 0. So what part of the graph is greater than 0? We have here and here. So how do we write this? What regions are shaded? At 2 and 18, we have less, k has to be less than 2 or greater than 18. And write an or in there, and that's about it.